related to the project to develop the design for each of our facilities. As many of you may know, the Houston Independent School District is currently in the midst of a major bond program. It's $1.89 billion. We are replacing approximately 20 high schools, including ones like the Energy Institute High School, and renovating quite a few others and doing other different projects throughout the district that are sorely needed. Part of our process in designing this project is to work with the campus administration, parents, teachers, students, etc., to develop what we call guiding principles. These are going to be the overarching ideals, goals that we as a project team, meaning both architects, designers, district, campus administration, will work toward to evaluate the project throughout, guide the project, guide our decisions as we move along the process. So I wanted to touch on a few of those, so as you develop your case studies and your concepts and ideas, you'll have those to draw upon. You'll be thinking in the same frame of mind that our team is working, and so your projects will then fit seamlessly into our projects. One of the first things is we really, throughout our bond program, we are pushing very hard to develop 21st century learning facilities for our students. A 21st century learning environment. A lot of people say, okay, what in the world are you talking about? What we found in talking with business people, and there were even a couple of studies by the Association of Management Professionals and a couple other different groups, say the biggest skills that they need from students, whether they be high school, college, graduate student, is students who are collaborative, can work in a collaborative environment, creative, innovative, and they're finding that that's what they have to do in their workspaces. That's why you get workspaces like Google, like AOL, and other spaces that you see, work environments that are changing. Toyota has changed their whole factory concepts, and so they can be more productive. Our industry is changing, our economy is changing, and we're changing to go with that. So one of the key things is we need to provide open, flexible, collaborative, creative workspaces. In other words, we need to create environments that will promote the kinds of skills and allow the kinds of skills that our students need for the future. So as you think about your ideas, if you would keep those kinds of things in mind. We have some different names for our facility, for those kinds of spaces. As we talk about collaborative spaces and creative spaces, we talk about the water cooler space. Students need an opportunity to come together and share ideas and take a break. Those collaborative spaces may be everything from the cafeteria to the library, media center, to wherever, but the idea is to create those opportunities even up and down the corridors in any space possible where students can have these little, I call them accidental collisions. They stop, they talk with each other, they share ideas, they stop, find spaces to work on projects together. They have to have spaces to be able to illustrate those ideas. So all surfaces need to be writable surfaces. You need to think about that in spaces where they can just sit down and do that. We also need spaces where students have individual focus areas. Not everybody likes to work in a big crowd. Sometimes you just need a minute to yourself. So we have cave spaces. And so throughout the building you will see what we call cave spaces. They're small spaces, 1 or 2 people. Go in, reflect, read, do whatever you want to do, work in whatever way you want to. But the idea is having these multitude of spaces within the building, and having the building is technology, is environmental systems, is technology systems, all seamlessly integrate and kind of quietly, ubiquitously be a part of that. And then finally, we need presentation spaces, or what we call mountaintops. We need mountaintops for students to be able to present. Just as you'll be doing at the end of this competition, one of the skills that the business world has said is extremely important is the ability to be able to present. And as you know, in having to do presentations, not only does that solidify your ideas when you're learning, but presenting peer-to-peer, interacting peer-to-peer, probably is a more effective learning than someone like me standing up here lecturing to you and just spewing out information. So those kinds of spaces and having those are important. Our technology has to be seamless. The question is, what is that technology going to be? Next week? Next year? 5 years from now? And all that. So our facilities are being designed with an extremely robust infrastructure. And we are making it as flexible as possible in terms of how we plug in to the building, how we plug into that technology, how we use that technology. All of our facilities will be wireless, but instead of the typical computer jacks you see now, most of these facilities will probably have USB connectors in the walls, in the tables, everywhere else. I imagine by the time some of these open, that'll be old technology as well. So we're trying to plan for all of those things, but more than anything, we're having a very robust infrastructure to be able to allow for that. Our buildings are smart. That technology permeates throughout the building. Not only is that technology for the students to use for learning, the teachers to use for instruction, but the buildings themselves are smart. The buildings understand when students are there, what the students need. They also teach back to the students. So in several of our buildings that were built part of the 2007 bond program, the building gives out a regular readout to the students as to how much energy is being saved, how many bottles of plastic bottles, water bottles are being recycled, those kinds of things. So think about that as an opportunity. As you come up with the systems and your alternative energy strategies, how can the building come back and teach the students, and that be part of the teaching element for the students? And one other item I want to touch on before I sit down, we really want to be part of a larger energy community, and that's why I'm kind of excited about this competition. Energy Institute sees a real opportunity for themselves. We are near University of Houston, of course, another university, and I think that's a perfect thing. We're right on the I-10 corridor, and although this end of the I-10 is not the energy corridor, by being on I-10, 45, and then easy access to I-10 makes us very close to it. We have Schlumberger and its neighbors not too far away. So we have some real opportunities for partnerships and opportunities. We want the Energy Institute to be a nexus for those partnerships, where industry comes in, the community comes in, and works with our students, where we actually are doing research here. And wouldn't it be nice if we're able to display in the Energy Institute some of the new ideas in alternative energy developed by our friends over at the University of Houston? That's what we would really like.
You have another slide, Dan.
I'll do that one more. Well, you see some of that. Oh, and pathways. There will be several pathways, and you see one of those pathways is alternative energy. And that's one of the things you're going to be looking at. But also technology, big industry for us. And then, like I say, I mentioned about the energy community and that partnership. All right? So that just gives you an idea of framework within which to work. Again, the importance of the 21st century learning environment can't be overemphasized. We've already seen, even though we're not that far into the 21st century, we've already seen where a different learning model makes a difference in student performance. And so that's what we're going to be trying to achieve as we move through this. And we're going to talk about a little bit of the project. Thanks.
Thanks. Hi, everybody. My name is Jim Jelliff, and I'm an architect with VLK Architects, and I'm a senior designer with the firm. I'm also joined today by a fellow colleague and architect who happens to be a University of Houston graduate, Angel Rivera, who at the end is going to talk to you a little bit about sustainable concepts and LEED. And if you don't know what LEED is, that deals with the leadership in energy and environmental design concepts. I've spent my career as an architect specializing in educational facility design, and I've had an opportunity to do it all across the United States, from coast to coast and from Canada to the Gulf. And as an educational architect, sometimes I find myself, in order to design buildings around that foster and enhance the educational experience, don't inhibit it, you have to understand some of the things that Dan was talking about with regards to 21st century learning, because it's totally changed. I mean, when I was a child growing up, they hadn't come up with all these new diagnoses for ADD and other things, but I was one of those. I was a very kinesthetic type learner, very active and stuff. I wasn't an auditory learner and those types of things. So we have to design facilities that support all the different learning modalities. And I'm having a Halfheimer's moment right here. ways in which children learn. So what we have and what we've been charged with, and we've been working with Dan's department, he's joined by a colleague, Luan Harris, who's in the planning department, is to design a new high school for the Energy Institute that supports 3 different pathways of education plus a 9th grade. And we went through a design charrette, and we have a site here that is about a 12-acre site. And you'll notice that we don't have one contiguous building. We presented various different options and concepts, and this was a concept we called the campus concept that was narrowed in on, that is made up of a 1-story building, a 1.5-story building, and a 2-story building. And I'll get into the particulars of what each one of those houses in a moment. But we have a site. We have to make sure that visitors parking and delivery is normally separated from, see, I told you, I do that all the time. Normal traffic here becomes, and then we have issues of bus loading and unloading, so there are safe pathways for students and interaction that you need to think about when you go through this. I'll tell you right now that we want to maintain as much green space as possible on the building for several reasons. As like anything else, this school will probably grow in time, and we'll need to have a strategy for how to add on to the building. But also, we have to accommodate parking too, and I think the number is somewhere around 350 or something. So as you're doing this, all total, I would factor in parking for about 350 cars that are made up of the visitors, faculty and staff and students. Freshmen and sophomores don't drive to school. It's really reserved for the juniors and seniors. And we have a primary street and a secondary street. The properties to the north and to the east, they're landlocked and primary residential or commercial spaces. And so that concept kind of translated into, and we're starting to develop massing and starting to develop some actual drives and scale. So basically, what we've done is we have more or less limited a lot of parking to the perimeter of the site with a visitors, parent drop-off, visitors parking area here, and this is more faculty parking, and buses come in right now and loop around, and this is the main bus entry into the building. So you're going to find that our plans at this time are very conceptual in nature, and they don't contain a lot of detail. We have just, as of our last PAT meeting, which is the, the project advisory team, which is made up of faculty, community members, students, people from the planning department, and the architects and our design team. We have arrived at an agreement on the overall building organization. We have not gotten into the details of the specific design of all these spaces, but we have come to agreement on their general relationship to one another. So the program for this, because of the pathways, are designed around 4 neighborhoods, or what we're calling learning communities. And there are 2 one-story learning communities here, and those learning communities consist of a large, open, collaborative learning space that a lot of these learning spaces open up to. It's about 2,700 square feet. There's a career and technical education lab, which is, each one of those programs is specific to the particular pathway, whether it be offshore, geoscience, or alternative energy, and then the freshman class has an introductory to engineering program. A wet lab, which is a science learning center, and then those LCs stand for learning centers. We in our industry have been moving away from the term and the use of the room classroom, because classroom has a sage on the stage, and that's not what education is about. And then these small Cape huddle rooms, and so the whole object of this, and then there's a teacher work center. So are there any architectural students in the crowd, or just faculty members? Okay. These guys really understand about what project-based learning is all about, because that's what an architectural program is. It's all about project-based learning, very collaborative in an open, engaged environment. And so they, when I first started, we first started in education talking about this stuff, I said, perfect example of that is an architectural education. We ought to just take all these people to an architectural school and show them how it operates and what a mess it can be, but it's very good. And it was a learning environment that was perfectly suited to my the way in which I learned. So we have that. And then we created a building that houses support functions, food service, and PE. And then we created two other houses right here and here that, rather than being one story, are those learning communities stacked one on top of the other. I mean, within each other. So the learning centers and huddle rooms and teacher planning, they all open up, and so it's a more dynamic space. The main entry is to the south off the main center, so there's an academic portion here, and we have some academic support spaces. This CC stands for a college center, which is relates directly to guidance and other career choices, but it's really a classroom, if you will. There's a computer service center, there's an art lab, and that media lounge, that's what that is, what we all used to know as the library. And then on the second floor, we have a large group instruction area of about 2,000 square feet that's going to be used for presentations and other things. This high school is not like a lot of other high schools because it's not a complete comprehensive high school, so there are a lot of programs that you would find in a normal high school that are not going to be contained in here. We don't have a music department. We don't have a full-blown athletics department, and other things. It's really geared more towards the education in energy, but there are things and requirements that have to be met within the state of Texas. So art is in there, and there is a physical education component. The total building, the total program, this building's designed for a capacity of about 850 students. When it's full-blown right now, when Houston starts new schools, they don't start with all 4 classes necessarily. Last year was their first, they had a freshman class. This year, the freshmen are sophomores, so we have a new freshman class. Next year, there'll be 3 classes and then 4 classes. So right now, we only have freshmen and sophomore in the building that they're currently housed in. So the other thing is throughout the design, we've tried to create areas within the design that create a direct connection from the learning environment to the outdoors. We have a large courtyard, and there's a variety of spaces. Not all of those outdoor learning areas are just open. They're covered. They have protection, so students can move freely back and forth between the inside and the outside. We're looking for a lot of transparency, a lot of natural passive systems for daylighting, heating, cooling. We're trying to pay a lot of attention for proper orientation of the building on the site, for solar heat gain, daylighting, prevailing winds, those types of things. There are a lot of things that you can do that don't cost any money that can save you a lot of energy in a building. So what we've done is we've also started to do some massing studies. This is a view of the interior courtyard. And doing some shading studies. This happens to be about high noon in the middle of June. And so there's a lot of sunlight in there, but there's this large, and you'll see it later, shading device of which currently we're thinking about putting a PV array on the top of that for solar gain. Creation of some other huddle spaces out here, gathering spaces. There is what we call a learning stair, or something that's tied directly to an outdoor learning space. There's that learning stair again right here. If you recall back in this plan, right here, if you were having a function going on in this large group area, this can be a surge space that can spill out onto this outdoor learning. There's just a lot of different ways in which that space can be used, and that's the objective. This is a axonometric view massing. This is the two-story building here. CTE labs. We haven't worked out all the fenestration on the building yet, so have at it. The only thing you really can't do is you can't screw with the overall orientation of the building and the arrangement of the building, but if you want to play around with massing and fenestration and all that, have at it. But here's that shading device, and this shading study, this was taken about this time of year at about 2 o'clock in the afternoon. You'll notice that 90% of that outdoor learning area in this courtyard is in shade. How come this isn't working, Sarah? It's not moving forward and backward. Did I kill it?
Turn it off.
Did I turn it off?
It's just not working. It's good. Use this.
And this, I believe, is my final slide. This was a first pass at what, on the site, that corner of the site, which would be the southwest corner, is a major corner and intersection where this building is going to be placed. And we wanted to take as much advantage, and that's why there's kind of a kink in the plan, because we kind of wanted to open that plan up, to open it up to some central element. So we're looking at that media lounge and large group instruction as being some sort of element that comes up. The orange, some clear story. This doesn't show it, but there's some screening on that. But this is a very preliminary image. I always hit the wrong button. Some sort of signature thing helping identify the entry. This is that large shading device that is over this outdoor learning area which this space spills into. So with that, I'm going to turn this over to Mr. Rivera, and he can talk a little bit about LEED.
Thank you, Jim.
Yep.
All right. Hi, everyone. Glad to be back. My name's Angel Rivera, College of Architecture, class of 2005. Glad to be back. I was actually back here this last Saturday for the Win versus UNLV. Did anybody go to that game? Anybody? Couple? Yeah. It's funny, now I actually get to go to the games now, because I never went to one game while I was at the College of Architecture, as you two or a couple back there can attest to that. But anyway, glad to be back. I'm happy to be here. And I'm just going to go kind of touch on what Jim was talking about a little bit and go into LEED. Does anybody know what LEED is? Can I get a show of hands? Okay, that was a few more than I thought. Okay, well, let me just preface this by saying we could spend an entire semester talking about LEED. We've spent a lot of time at the office talking about LEED and what points to go after. So I just want to start off by saying, don't get caught up in the technicality of all these points that we're going to go through, okay? I want you to use it as a tool, as a guide to help in your designs and your projects. Don't get too caught up in it. This is going to be an ideas competition. We want to see your amazing ideas and creativity that you can bring and give us to this project. So, like I said, just use it as a tool. LEED stands for Leadership in Energy and Environmental Design. And what it is, it's now an internationally based system that basically assesses buildings and their sustainability. How sustainable are they? What happens is the design team will do an initial submission talking about the LEED points that we're going to go after during design, and then after that there's a construction phase where we talk about the construction, and you basically submit all your documents about the points that you're going to go after, and then you have a third party that looks and reviews those documents and make sure the calculations are correct, and they basically give you an accredited rating system. Here are the different certification levels. Now, working with the school district, our contract requires us to get LEED Silver right here, okay? Certified is 40 to 49 points, Silver 50 to 59, 60 to 79, and then Platinum. You'll be surprised, there's actually a lot of Platinum buildings that you'll see even downtown. And I was at an event yesterday and found out that in the 770072 area code, now that's just basically the downtown area, we have over 96 million square feet of LEED certified, that would be across the board, square footage, which was pretty impressive to me. I think that's, we're right behind Washington, D.C. and San Francisco as far as cities with square footage with LEED buildings. So LEED's not going to go away anytime soon. This has been around. I was learning about LEED when I was back here in the College of Architecture with Mr. Bachman here and some other professors. But I'm going to quickly go through our checklist. Again, there's a lot of detail in it, and we're going to give you some resources that you can use to apply to the project that you're going to do. If you have any questions, like I said, it can get very detailed. Feel free. You're going to have access to emailing us, and we'll help you with any questions that you may have. Working with the school district, they give us some guidelines on certain LEED points to go after. Some we're not allowed to go after. With this competition, we're going to keep it open, okay? Like I said, this is an ideas competition. We want to see how imaginative you can be, how creative you can be. We want something that's going to scream energy, okay? This is Energy Institute. We go into our, let me pull up the PDF. Here it is. You can read that one a little bit better. Okay. So what LEED does, it basically breaks things down into certain categories. And the first one we're going to study is sustainable sites. So you're going to get a checklist that's actually blank, and I believe we'll go ahead and upload our initial checklist. Now what happens is what we do, we have a meeting in-house. We'll invite our engineers to come sit down on a round table. We'll have our designers there, and this is the first thing we'll do. We're going to run through this checklist and say, can we get this point? Does the district let us do this, go after this point? And you'll see up here it has 3 columns. The why is for yes. Question mark is, yeah, maybe we can get it. We're not sure, but we'll go ahead and put that point there. And then, no, there's no way because site constraints or whatever other factors we weren't being able to get after that point. So sustainable sites, again, being very broad about it. It's basically like Jim was saying, how are you orienting your building on the site? Did you use a site that was brand new and had never had any development on before with all these trees, and did you have to come through and slice all those trees down? Or did you use an existing site? Okay, you're going to get points for that. Okay, if you use a site that has a bunch of trees and you knock the trees down, that's bad. You don't want to do that. So they're trying to promote using existing sites, urban land use. So that would be site selection that you see here. Development density and community connectivity. These are points that are based upon how dense of an area are you in. Do you have bus lines coming by your site? Do you have access to bike trails? Do you have access to light rail? You get points here. If you had a site, you guys have the new light rail that's coming through. So that would be points. You're getting points in that. And so the more points you get, the higher you can get as far as the ratings. And like I said, we're going to go after silver, and if we can get gold and platinum, we're going to do that. We're going to urge you to shoot for platinum for sure. But again, don't get too caught up in the details of it. I want to see imaginative, creative ideas from you, using this as a tool. So we talked about alternative transportation, public transportation, bicycle storage. If you have showers in your building, so if someone takes a bicycle to the school, they can shower when they get there. Parking capacity. Again, protecting or restoring the habitat, kind of touched on that a little bit. Site development, maximize open space. Jim touched on that. We want to see a lot of green space. Okay? We don't want to see zero lot lines and you've seen those houses somewhere and you have like 2 feet away from their neighbors. No, we want to see lots of green space. And be creative on where you put that green space. We don't want to just see you have a square block and the building's here and then you have a green space here. You'll see you want to mix in that green space in the design. Heat island effect non-roof. Okay, this is, you ever walked in a parking lot, black asphalt parking lot, notice how hot it is? It's called heat island, okay? That black asphalt is absorbing that heat and bouncing that heat back into your face, and that's what's making you sweat. So if you're using concrete, which has a lighter surface, it's going to reflect that sun instead of absorbing that heat. Then you have heat island effect roof. Again, this is the same concept, using light colored materials, even green roofs, anything that's going to help deflect the heat from the building. Light pollution reduction. And this is not having one of those obnoxious, what I call a glare bomb on your neighbor's fence. I don't know if you have, I have a neighbor who has a patio light. It's a motion detector light right outside my kitchen. And every once in a while, a dog or a cat runs by, this big light comes off. He's polluting my space. Light pollution. So we're going to try and do lights that are down lights. You don't want to have lights that are up and reflecting light up into the sky. You want to have lights that are down. So that's pretty much with sustainable sites. The next category will be water efficiency. This is just talking about being innovative with your water. Are you taking the water and recycling it, using rainwater catchment systems to irrigate their garden? People are now actually putting filters on them. And water's a big topic. We don't hear a lot about it now because we have a huge lake just to the northeast of us that we don't have these problems. But when you hear, places like California, they have some serious problems with water. So this is just talking about reducing the water usage on your site, not using irrigation to irrigate the site, using native plants that are not going to require a lot of water to thrive. Another topic is energy and atmosphere. And this is more, you have engineering students, anybody from College of Engineering? Okay. This is going to be some more engineering mechanics systems. This also ties in with IEQ, environmental indoor indoor air quality, but this talks about the energy of the performance of the building on the mechanical side. Refrigerant management, using not using a lot of Freon and things like that. VRFs. Okay, next category, materials and resources. This is when I talk to people about materials and resources, I try to sell this as more, this is like a health aspect to you. They're doing a lot of studies now on these materials. You hear about asbestos is probably the biggest one you've heard about, but a lot of some of these materials they're doing testing on, and especially with the solvents and the adhesives, they have cancer-causing chemicals, what we call VOCs, volatile organic compounds, that are bad for you and banned in a lot of places. So this is talking about using materials that are recycled. If you had an existing site in a building and you knocked it down, were you able to salvage any of that material and reuse it? So you have points here, and what this does, okay, like for construction waste management here, if you demoed a building and you're diverting a lot of that waste into landfills, if you're able to divert 50% of that waste, you'll get a point. Well, what we're doing here is we're saying, well, you know what, we can get 75% diverted to a landfill, so we're going to go ahead and get 2 points from that. And you'll see that through some of these lead points that you're going after. It'll give you, okay, if you get 10%, you get 1, all the way up to 100%, you'll get 10 points. So depending on how you perform in that percentage will dictate how many points you get out of that. Again, I talked about materials reuse. There was an existing building on the site, but it has already been demolished. Is that correct?
It has been demolished.
Okay.
But that's also talking about during the construction process, whether or not during the construction process, how much of the waste is going into a landfill and how much of it is being recycled.
Right. Okay. IEQ, indoor environmental quality. No smoking. Jim, no smoking. We have an office building, and there's a little smokers area. It's 25 feet away from the building. Well, here we're not even going to allow that. There's probably not even, I don't think they allow smoking on campus at all. So, but for other buildings, again, if you do smoke control systems or have dedicated rooms where you have smoking, that's where you can go after these points, where you have a specific room that has a special dedicated ventilation system that's not tied into the other mechanical systems that takes the smoke out. Ventilation. This is one of those things it's what we call a passive system. This doesn't cost us any money. Can you open up the windows and get a natural breeze? This would be an amazing day right now to go home. I'm going to go home and open up my windows and get some increased ventilation. As opposed to just having a solid window that you can't open at all and you get no breeze and you're just having to use breathe the air coming from a mechanical system. Again, materials and resources also tied into that, and the air quality. When I was talking about low emitting materials, you have adhesives and sealants, and we're going to go after all of these right here. So we're going to use adhesives and sealants that don't have VOCs in them, the paints, the coatings, the different types of materials that we're using, even down to the furniture and the furniture that we're doing. When you buy that new car and you sit in that new car and you're like, man, I love this new car smell. No, those are a bunch of toxins that you're smelling right there. So I'd rather go get to one of those air filters with the new car scent. That's definitely a lot better for you if you're going to use one of those. Okay. Daylighting and views. This is another one. When I was in elementary school, I went to a school that had, one of the classes was in the center of the building, and I had no windows outside. And I knew I didn't like that class for some reason, but maybe it's because I couldn't see outside. Now this kind of goes, I hear some teachers that don't like the students because they can see outside, but they've done tests and said that even in working environments, in working offices, you have people that have visibility to the outside and natural daylight, they're going to be more productive. All right, innovation and design. This one is where we're going to get to see your creativity. Innovation and design was put in there from LEAD and says, okay, we've given you a list of things to go by, but man, if you can come up with something that's cutting edge and new, this is where you're going to be able to use that. Okay, so this is where, I mean, if I were you, anybody can come in here and fill this list out and say, okay, yeah, I'm going after that, I'm going after that. We're not looking for a really good filled out LEAD checklist. Okay, we're looking for, like I said, this is an ideas competition. We want to see what ideas you can bring to the table for this project. So be creative with that.
Of that, about ideas. You know, buildings have windows in them. Do you put the same type of glass on all the windows, whether it's on the north side, the east side, the west side, or the south side? In the old days we used to, because that's all that was available. Today, there are different types of glazing systems that can go into windows that there are windows out there, for example, that have an R resistance factor of 7 or 8. Typical window insulating glazing unit has an R of 2. All right. Now you're going to pay a little bit more for that RA glass, but you have to balance that off against the impact on your mechanical systems, your heating and your cooling, and other things. So it's not always about first cost. It's about life cycle, long-term costs. And this goes into a wide variety of areas. A lot of schools were done with vinyl composition tile, what we call VCT. Those are very labor-intensive flooring systems because every year, a couple times a year, school maintenance people go in, they strip it all out, and they have to wax it, apply 5 coats of wax. So then there's all the buffers and buffers. So are there other flooring systems out there that still perform at a higher level, but don't require that level of maintenance? To me, that's energy. I mean, there's energy savings involved with that. And there are dollars that are saved that can be diverted into the general fund to educate students. It's not about maintaining the building.
Okay, thank you. Well, again, that was a quick run-through of LEAD. You're going to have a lot of resources to use. There are other rating systems out there. I would look up the Living Building Challenge. It's something on par with LEAD, but it's a challenge. It's more challenging than LEAD to kind of get accredited and get certification in. So there's a lot of resources out there, and we're going to get you some links that you can go out and research, not just LEAD, but some other things to kind of help you come up with some ideas.
And I was just going to add one more thing to you. You may ask yourselves, why are we making such a big deal about sustainability and energy and why the competition? Well, besides the fact we enjoy working with students, the Houston Independent School District maintains 644 permanent buildings. We maintain another, unfortunately, 2,200 portable buildings, transportable buildings, T-buildings is what we call them. We have over 29.3 million square feet of space, floor area, in the Houston Independent School District. You want to guess what our light bill looks like?
It's a 6-digit number.
Yes, easily. So energy saving, sustainability, alternative energy ideas is absolutely crucial. But even as bad as that is even because it's a big bill. Needless to say, CenterPoint and Green Mountain Energy, they like us. They like us a lot. But we've also found that sustainable facilities improve student scores. They improve student scores by as much as 3 to 5 to some studies even say as much as 7 percentage points. We have some of the projects from one of the projects from our 2007 bond program, which is a LEED Gold facility. Students in that same facility, the new facility in the old building, moved to the new facility. And within about a year and a half, math scores, Stanford math scores, improved by 20%. Now, I want to think that's also because teachers changed and, there are other things, but there's no doubting that the sustainable, energy efficient, alternative energy ideas contributed and played a part to the way the students performed, probably played a part in the way the teachers performed. And the other part of this too, and while we're looking for some really great ideas from you, the building becomes a teaching tool too. And I think those are all the kind of things. If I have to pay a big light bill, I'll pay a big light bill. But if I can see student performance grow, then this is really great. So we hope you'll really help us with that and everything. So, Sarah, we're trying to keep.
Yeah. All right. Now we're going to open it up to any questions. I could talk about LEED. Does anybody have a question about LEED?
No, I was going to ask, I saw that marketing was checked out as something that would be feasible. Is there a reason for that, or is that just something I'm reading on? There was something about bikes in one of your sections that you guys checked out that is not feasible. Was it bike storage and
There are certain you don't have to do what according to our, but there are certain lead points for us when we're working with certain clients that we're just told not to pursue. It's not, it's not that we can't pursue that, but in order to pursue it, we have to sit down with the client and give a pretty good argument of why we feel it's necessary. Unlike when I was going to school, I walked to elementary school and to junior high, and I rode city buses to school. A lot of kids today, doesn't matter how far or close they live to their school, they ride a school bus. Or they have some other alternative transportation in terms of a parent taking them and dropping them off. We don't have, in the public school system, a lot of kids riding bikes to school today. And it's a shame that that's the case, but we don't live in as safe an environment as we used to when I was growing up. There are a lot of reasons for it, but so that's why.
Well, let me add to that. Again, we're going to open this up to you. And, if that's something you feel you have a concept on that involves that, don't let it hold you back, okay? Go ahead and go after it. Yes.
How limited are we in terms of implementation? If we want to do, say, put a cooling station, I know a lot of some cooling cylinders, obviously that would fit within the design area that we want to implement that would cost X, but say X in the long run. Are we allowed to do these type of things, or?
Absolutely. Yeah. Please do that. And I didn't touch on it. Life cycle analysis. If you can say and prove it to us and say, yeah, you're paying X amount of dollars up front for this, but you're going to be saving on that square footage that Dr. Banghead is saving or having to pay, then in 10 years it'll pay for itself, and then after 10 years you're making money off of it. Absolutely.
But really what impresses is if your cooling station was powered, not just by plugging it into the wall, but by some other means or something clever system.
Right. So it would most likely be done with chemicals, just to improve the thermodynamic processes of the entire campus, not necessarily powering through. And then with that being said, on the thermodynamic processes, how much are we allowed to tinker with, say, the grid supply to the buildings themselves? Are we limited just to everything that is, above the ground and everything that's being built right there? Or are we allowed to tinker with the existing infrastructure that's going to be plugging into these buildings at all?
I want to see what your ideas are. So, yeah.
As a general, I guess I would say, I think you're absolutely right. And I think as a general guideline, we typically tell the architects, we would tell these guys, up to the property line, we can impact. We also, though, as one of the largest customers to CenterPoint and Green Mountain and all the other various energy agencies, we also have some opportunities to say, hey, we're your biggest check writer, work with us. And I know there are other school districts around the country who have looked at alternative systems to the point where their schools are actually feeding energy back into their grids and all that. So those, I can't emphasize enough what you said. That is, bring us everything. You know, it's because for us to sit here, we may not have thought it. We haven't stretched our brains like you are doing to think about what those possibilities are.
Absolutely.
If there was ever a building that screamed to be platinum net zero, it's this one. So.
Yes.
So on the bicycle topic, and is this like a magnet school where there's kids from all over Houston, they're going to be funneled to this from 20, 30, 40 miles away?
Yeah, it's a magnet school. I mean, you're going to have kids coming from all over. It's not your neighborhood high school.
Yeah.
So I know you said we have a lot of flexibility, but did you cover budget, or is there any?
The budget for this the overall square footage of the building, the program square footage, total gross square footage is around 110 or 112,000 square feet. And I believe the budget's what, 23 or is it 28 million or something like that?
I think it's right at 23.5 or 23.8 or something like that.
million.
Almost, you could almost call it 24 million and everything. Now, one thing that, as I mentioned, we're doing kind of a different type of facility. One of the things you'll see in these projects, the technology money is a separate above and beyond that 23.8.
Furniture.
And then furniture is also, and we're building less into the building because we really think the whole environment for teaching is changing so much. We don't want to build very much in. A lot of things will be flexible, movable furniture that we can replace frequently, even down to the walls are operable and change.
The only, I mean, when I've looked at it, Dan, in terms of what's been written in the ed spec, the only portion of this building that is heavy on any sort of built-in equipment are the science labs. I mean, almost
And even
everything
there,
else is furniture.
Yeah, and even there, they're around the perimeter is
Yeah.
what our concept is. Everything else flexible and movable.
Any other questions?
In terms of design, are you using your guys' schematic design as a footprint, or we can alter the design?
You can alter that. I mean, you just can't really, the relationships of the thing.
Let me go back to that floor plan.
I'm not the one who is setting the guidelines for the competition or anything like that, but if there are improvements or things that you can think of in terms of the overall performance of this building from an energy standpoint, have at it. But if you notice, this building primarily has a north-south orientation and trying to minimize east-west exposure. Now, there's some spaces just can't be avoided, but like most of the academic wings, 3 out of the 4 have primary north-south exposure.
Okay. Yes.
You talked about and the goal is to get to sort of platinum status for the league, but for our purposes, is that really should that be, it almost seems like it'd be difficult to try to do that as well as coming up with different ideas. We can see, is the purpose of the exercise to come up with ideas, or to come up with ideas that are specifically oriented around gaining as many points as possible?
So this is more about the ideas and concepts that you can bring to the table. Like I said, just use this as a guide to kind of get you going. Like I said, anybody can come in through here and check yes on every one of these points and say, I've got a platinum building, okay? But if I have someone that comes with me with some brilliant idea and he only had gold, but he brought something or she brought something to the table that was innovative, that we haven't thought about, that we can actually possibly use in the design, then that's gonna benefit you more.
You're gonna have to balance all that, because this young lady who asked about the budget, all of this and everything you're doing and everything you're proposing still has to be done within what our proposed budget is. All right, so if you have all these great ideas that takes the building to platinum, but you busted the budget by 15%, then you failed the challenge. I mean,
Will we have a chance to see kind of the basic outline of the budget? Like what you envision?
well, I can tell you that basically what will happen here is that we're saying that for this, we have $24 million, and that's $24 million. We'll just say that that's $24 million for construction, all right? You don't have to worry about the technology piece, and you don't have to worry about the furnishings piece of the loose furniture. And under a normal situation, all right, your site work, and given this is an existing site and some of that stuff, I would factor in that site work's going to cost you on a normal project without any far-blown enhancements or stuff. Normal civil site work is going to run you anywhere from 10 to 14% of your total cost. Okay? Structural systems are about 10%. You know, but there are things you can do with the exterior envelope. That, I mean, this is all about. It's an energy challenge, right? And so, what are the things that you can do in terms of the design of the building that are going to enhance that performance and still be able to do it within budget? I mean, that's right, isn't it?
Now, I will offer you a lifeline in that process as well, though. I will tell you that other school districts and even our school district have been approached by various people to say, we are really interested in you using our new technology, our LED light systems. And we are so interested in the 5th largest school district in the country using our LED light system. Tell you what, we will sell it to you at cost. Or we are so interested in you using our flat PVA solar panels that are film solar panels, we will give those to you as long as you let us advertise that 5th largest school district in the country is using our panels, and therefore, or that you feed that electricity back into the grid for the first 25 years at no cost to us, and then after 25 years, we pay you for whatever you feed back in. So, I don't want that to limit you. I really am interested, but Jim is absolutely right that we really do have to be conscious in a project like this. And I guess part of why we're saying this too is we hope we're going to get some good ideas, and we're hoping we're going to be able to incorporate it. We don't want to do this just for the sake of doing it. We're hoping we're going to see something that we can say, yes, we didn't think about that, we like that idea, we want to see that at the Energy Institute. And that's part of what will help us do that, is if it's within our budget, or there's an idea with it about how it can be worked into our budget.
I'll throw one of these things out here. We recently had a manufacturer come into our office and meet with our staff over lunch and stuff, and introduced a product called Sundelier. All right. Houston, Texas has sunshine 62% of the time. It rains a lot here. But, and this gets into whole lighting studies and what you understand about lighting, between artificial lighting and natural lighting and lumens and what you can perceive and all that stuff. But you have this one 24-inch penetration through the roof, and this thing, this parabolic thing, it follows and tracks the sun and its altitude and azimuth 365 days a year. And out of that one 2-foot round opening with the proper design and stuff, I can light a space of probably close to 3,000 square feet. And I don't have to have light fixtures on. Now, something like that's going to run you about $20,000 or something for that one thing. That's where you have to you have to balance the costs and the benefits of those, and you're not necessarily using that everywhere, but maybe you're using that somewhere, and somebody on your business side and your engineering side figure out what your cost savings are for those days that you don't have the electrical light switches on and stuff based on that. And let's say that thing pays for itself in a year and a half. Well, it's worth the investment, you know?
And by the way, if you do use light sensors and occupancy sensors as one of your energy ideas, do have an override, so when people are sitting in the auditorium and talking with each other, the lights don't go on.
I did a school in Waldorf, Maryland, elementary school. Tons of natural daylight in this building. And I go into this building, I'm walking through it, and all the lights are on. In all the public areas, all the lights are on. I said, why are all these lights on? Well, the maintenance guy says, because your engineer only put one switch and it's at the main back in the mechanical room, you know. There wasn't a convenient way to turn the lights on and off. So they could have almost all of the lights in all of their corridors and their major spaces in that building off most of the time. But they're left on because there was no convenient way to control them. It's ridiculous.
I saw one way in the back there. That's your hand up.
Are we gonna get like, you see like schematic plans for like a 3D printer, or we do like energy modeling and see what kind of like things is
Yes. So the question was, are you going to have access to these plans? Let me start off by saying this is just a very schematic with not a lot of detail. You will have access to these, and we can get you some of the program square footages for the spaces for sure. But this is going to be a work in progress. So what you see today might, and I can just say it won't be the finished product. But yes, we will give you these slides and some program from the space that you can use for that energy modeling. Go ahead.
What's an average cost for a conventionally built building? Because let's say you have like $218 a square foot, what your budget is. So it's a normal building costs like $150 a square foot. We can have like $70 to play with or something, or
No.
What did your calculation come out to?
You guys said 112,000 square foot for 24 million.
218.
Yeah, 110,000. That's a reasonable budget for that.
So 220 square foot. So if we're going to make these, like, I'm coming from the aspect we built a lead house and it costs us about 30% more for all the different stuff we put into it. So I'm just wondering, what's the delta between the conventionally built building budget this year?
That's what our challenge is, because there are a lot of people out there that can tell you that these buildings not going to cost any more money. That's where you're trying to find creative ways to solve those problems without having to open up the checkbook.
So think about that. You know. I like that you're already breaking out the calculations. That's nice. We'll do right up here, red shirt. Yep.
I have a question. You mentioned that
Mr.
you
Bankhead?
want the building to be a teaching component itself. You mentioned you want the building to be a teaching component itself. So what is it that it is? Like, what's the culture of energy in high school students? That's not really common from, students say, I want to be a geoscientist or something at the middle school time period. So what is it that defines an energy student, or how you select one to make that kind of culture you're establishing?
Well, for instance, some of the things we're thinking about is part of the building, either subterranean, and the wall against that subterranean wall is a glass wall where they can actually see the strata of Earth, and every day they walk by, they understand the strata as their teachers are talking about it. The energy, whatever energy saving system, alternative energy systems you come up with, are students able to walk down the hallway and see the piping or see those systems actually working and operating. And so it'll be interesting, and that's part of we don't have the answer to that completely, because we wanted to see what it would be. We tried to come to these without preconceived. But one of the ideas was, as you mentioned, for geoscience, was do a cutaway of the wall of the earth and show that, and or have a glass floor where they can look into a open pit or a boring or something like that. Do you have borings lining up along a wall, and the whole wall is nothing but a series of borings instead of just painted brick or block or something? We've taken cores from different excavations from the deep sea, from the Gulf or something like that, and captured them as a part of it. So there are opportunities, they're all kind, and I'm probably touching the surface of what they could be.
Yeah, there's lots of opportunities about that. We've even painted pipes for hot water, cold water for children in elementary school. So you can just get a visual. Hey, that's a red pipe, that's hot water coming, cold water.
Exposed structural systems. I mean, there are a myriad.
There's a lot you can do. Did you have a question again? There is an address. I do not know the address off the top of my head, but that will be given to you. You will have the address. It's actually close to here, so you can. I invite everyone to go out there and visit the site and get a feel for it, for sure.
Yeah, this site is located on Southmore. It's not very far from here. It's on the northeast corner of the intersection of Southmore Boulevard and Tierweiser or something like that. Tierweiser Street.
Tierweiser.
Okay. Anybody else? No? Okay. I think Sarah's going to step up here and have some closing remarks.
Thank you, Angel. Okay, so with that, I hope you guys got a really good understanding of what we're going to be doing with this case competition. I want to emphasize that this is not for you to design the entire school. We don't really expect that in a couple of months. It's just for you, if you looked at the LEED guidelines, so there's different breakdowns, you can focus on one of those areas. If you really want to do solar panels, do solar panels. If you want to focus on heating and lighting, please do so. This is very much an emphasis on being innovative, being cheap, and using the different ideas that you're actually learning in your classes and working collaboratively in cross-functional groups to be able to really innovate. So the team names and the names of all of the students are going to be due October 4th, just reiterating that. I'm going to make sure that you guys get this PowerPoint here and a lot of other materials that will really help you understand this case a lot better. This is kind of clear as mud right now, but I hope it gave you a good overview of what the school is trying to achieve and what the architects are trying to achieve. And another thing to put your minds at ease, we're going to have almost weekly conference calls with the architects, and they're going to be able to answer any sort of technical questions you might have or anything else that you might have come up with during the project, so you can have that guidance along the way. So I really encourage you to meet with your teams, talk to other students who didn't show up today. I'm recording this event right now, so I'm going to send that out as well, and make sure that your teams can watch it and get a good idea. And moving forward, if you have any questions specifically about the case, you can email us at info@eabauer.org. Come up and talk to our professionals for a little bit. I'm not sure you guys want to leave just yet. And thank you for coming out. We really do appreciate it.